Okay. All right. So new method for the day, Jefferson's method. We're just talking along the lines of we're going to do these apportionment methods and then historically look at something I stole off the internet about what happened specifically with our House of Representatives, how contentious it is to figure out the appropriate apportionment method, whatever that may be. It's always, I don't know, conditional is not the word. Depends upon where you're at, though, who thinks what is fair. So that's why these different methods came about and blah, blah, blah. So Jefferson's method. This is strange. And I thought I'd put this off to the side just to remind you what D and Q was. Remember, for the purposes of all of these things, step one is the same. You take your total population divided by the number of seats that you're going to give out for the House of Representatives. That's P over M. That's what D is. Then to get the quota for each state, you take each state's individual population and divide it by whatever number you got out of this previous step. Then that tells you how many representatives you should get. Hamilton's method, it's simple. Highest fractional part left over gets the extras one at a time. And then Lowndes method, I hope I'm saying it right. I didn't look it up. You do that. I forgot the word. Important fractional part. What was that first word? No, it's not important. Relative fractional part. The fraction relative to how many representatives you get. And then whoever had the highest one of those numbers ended up getting the extras. Well, Jefferson's method is completely different. Has nothing to do with any of those at all, except for step one. Step one is exactly the same. Find D, find Q, round down, see what each state gets. We're not going to do states right away, though. We're going to emulate an example that is in the book. Okay, so it is weird, and I'll get it in terms so you understand it. Now here's what's weird about Jefferson's. Completely standalone. You will not understand it when I give you the words for it. Okay, step two is strange. Okay, of course we know in the representative situation, when we round down and we add up all the numbers, are we short representatives or do we have too many that are given out? We're short. We round down, so we're short. So we're going to be short. So I don't understand why they say what they say if you're too small or too large. You're going to be too small. Not all the representatives are going to be given out. So what you do is do what's called choose a modified divisor. Again, this is only for Jefferson's way of doing things. He stops and restarts the whole process. The first check, doing step one, not all the representatives were given out. So we're going to modify the divisor and redivide. Okay, so what does he do? It's right here. This is the key. This is what you got to understand and write down. Jefferson thought, let's start with the largest state, the one with the largest population. Oh, my word. All right, here we go. And then divide it by its individual number that you got after you rounded down, plus or minus 1. But it's going to be plus 1 because we're going to be shorts on the representatives. So we're going to take that individual's population and divide it by its individual integer that they got for how many representatives they were going to get. Add 1 to that. What that does is makes our new modified divisor smaller. And what happens when you divide numbers by a smaller number? What does the quotient become? Larger. So therefore, we didn't have enough representatives before. Well, now we might end up getting more representatives, which might hit the number that we're going to actually give out. And the problem is this may not hit it right on the head. So you may have to do this again and again and again until you hit it on the head. So we are more than likely going to have too few seats every single time we do our representative example. So what we're going to do is change the divisor and redivide. So we're really going to have this pink here. Take the largest state's population divided by its integer that they got, 4 after we rounded down, but add 1 to that divisor. Then that's our new number that we're going to divide all the rest of them by. This would only happen if the first step we gave out too many representatives. Well, then we'd have to jump back and take the largest population divided by its integer, how many representatives they were going to get, minus 1. Again, this isn't going to sound great at all. Okay, you have to wait until we actually do a number example with this. Now, if this step does not work, a couple different things could happen. You could be too short again. If you're too short again, then you'd have to divide the largest population by I plus 2. If you're too short again, you'd have to divide by I plus 3 and go on from there. But the worst thing that could happen, actually the best thing that could happen, is your first one was short, your next one's too big. Then what you have to do is do a modified divisor as an average of the previous two. Now that one, we have to wait till we actually do a number example, and I'm going to do 2 of them. All right, and it's going to be tough, so you're going to have to wait for numbers before we ask any questions, because it's really hard to explain without actually numbers being thrown at you. Just telling my 5th hour that the divisions we're going to have to do is quite lengthy. I'm going to use the graphing calculators to do this as, an aid for what a lot of people are actually going to use, I bet. Actually pick this up and figure it out. Wait, that's been up there forever. Oh, you kids and you. All right, bottles of wine, high school, shouldn't be talking about it, but it's in the book, college book. Okay, so here we go. And this is a stupid question, but just to make sure you understand how it relates to the states and how you mess around with the numbers in your head, or like what the labels are. I didn't mean numbers. So I guess this is what happens. 4 friends need to split up 25 fine wine bottles that are kind of expensive. All right, that's enough. Okay, now, these 4 friends actually contribute a dollar amount, which should relate to how much they get. If all 25 bottles are equal in price. Okay, so all 25 bottles equal the exact same amount. So they contribute this amount of money. So here's what you need to understand. Does D equal total population divided by number of seats? No, it equals total amount of money that you put in divided by how many bottles there are, because you're distributing the bottles. So I should have just put bottles instead of 25. Just like, what are we distributing in the states thing? We're distributing representatives. We're distributing people. So total bottles. I can't fit that. All right, and then what's Q then? The Q is not each state's population. It's each person's money contribution divided by what we got on that previous example, the standard divisor. Okay? So that's, just so you know your labels here. Okay, well, the first step is still the same. Okay? You do have to, as you're writing this down, this is given, this is all given, nothing else is. You'd have to add up the total sum, divide this sum by 25. I do have that down here. And then this is the first divisor. We take each one of these dollar amounts and divide them by that divisor. So here's Jared's example. And then you go all the way through the chart and divide. Now, imagine if your chart is 10 numbers long. You'd have to divide 10 times. And you are going to have questions like, the question that we had Thursday, the chart was huge, right? Yes, Mr. Samuels. So I could have showed you this before. Don't look like you want to kill me back there. That's actually on a daily basis. All right, so this is what we can do. I'm going to start with the inspires. Are you ready for this? Bum, 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 bum. How many people are inspires? Raise your hand. Okay, I think I'm only going to show you a couple steps and you're on your own, because I cannot stand the inspire, especially on this computer. It's very not easy to type on. Okay, but I will show you where your situation is, how you can do this, and then when we go to the 84, all your steps are very similar. Okay, so, and then hold off 84s, because I'm going to focus on you mostly. Sorry, inspires. It's just, it works better on this one. Is this making us, Ultimately large. It is. Nice. Okay, so what we want to do first is hit the on button and then hit a new document. And what we're going to do is do a list/spreadsheet. So hit that. And then this comes up. Well, right away, you can type in your numbers. 295, enter. I hope it's working. Good. 205, enter. 390, enter. And then 180, enter. And now after my first hour debacle, I had a real hard time working on this computer. I think I know what to do next, and it'll be fine. Okay, now I know I have all these answers, but I'll show you how they come up, and there's actually one of these are wrong, based off of what I do here. I have to divide all of these by 4280 to get these decimals. So 4 in the list is not a big deal. I'd have to divide 4 times. Or you can go to B, get it ready so it says equal, and just type A. Guess what A is? A is the A list. And I want to divide the A list by 4280. 42.80. Press enter. Boom. Shaka. Anyone? Laka. See, that's the one that's wrong. This one's 0.20. And then what you can do is copy your list down. And then what you can do is each time you can go to C to do your next division or overwrite on B and do all your divisions that you have to do in the future right here. Okay? Now, here's the 84s. And that's your guys. I'm just going to do 84s the rest of the way. So 84s, it's completely different. This is why the TI company really makes me angry. All right? Because it's completely different and it's hard to teach both of them without doing it completely separate, like a different lesson. Okay. Here's where I was at that well, you didn't probably notice, but hit the stat button. Stat button's right here. See it? It's right there, right by the arrows. And then hit edit. Now, this is where a whole bunch of different things are going on. All right? And actually, I put something in a weird spot here, but how many people have L1, L2, L3 up there? You see it? All you really need is L1 and L2. All right? Anyone have any numbers in it? Okay, this is what you need to do. Don't do anything until I tell you. Because if you hit the delete button, it's over. L1's going to disappear completely. Go all the way up to L1 and press clear, enter. Go all the way up to L2 and press clear, enter. Go up to any list that has numbers. Clear the list by hitting clear and enter. Clear, enter. That's weird. L4, L5, okay. All right, and now you do the same thing we did in the other calculator. 295, enter. 205, enter. I swear, when the lists are longer, and actually when you see what we have to do with this stuff, you are going to want to know how to do this. Because I don't want to see your work for the dividing. I just want to see the correct numbers in the list. If I ask them for decimal form, then all you have to do is do this. Dude. Seriously, I'm going to have you stand up. All right? Have the correct numbers in decimal form and then round it down after that. Oh, the sound of my voice just it must be so melodious, to put them to sleep. Or her, because it's cryptic. We don't know who we're talking about on the internet. Okay, now what you guys have to do is this. See, if you had a calculator, you'd be typing buttons and then you'd be activated in the notes. But I'm just saying. Now go to L2 and hit this. Where's my list at? L1. Here's L1. See 1 right there? See 1? Look above 1. Look above 1. What does it say? Well, he's up now. Oh, and he has a calculator. That's amazing. He's drooling on he drooled on his calculator. It's short-circuited. I got it. All right. That's fine. I understand. Sorry. Okay. So hit second L1. What's above 1? 4. All right. Divided by 42.8. Do you see what I deal with, internet? All right, and then you get the same numbers. What do I do? You did something wrong. No, you did not. Let's go back up here. Go up to the name L2. As long as you got these 4 numbers written here, hit second L1. See how that says L1 right there? Divided by 42. Oh boy, it's 5th hour. There's anarchy going on. I got the wrong numbers. Let me pause the video. This is what we got. If we did Lowndes method or Hamilton's, you got to do the step first. Okay? Well, This is where it changes, completely different. When you add these rounded down numbers, we have 23 bottles. Is that how many we're giving out, yes or no? So now we have to redivide. Now this is where it gets weird. Who's the biggest number? Who's the biggest population? Who's got the biggest price? Yeah, Robert, 390. What we're going to do is take Robert's 390 and divide it by, since this number is too small, I want to get this to be 25 on the dot by some magical divisor. We're going to divide 390 divided by 9 plus 1. What that will do, I see faces. Well, oh, that's the wrong thing. This is fun. Star Wars. Okay, where am I at? Ay, caramba. Okay, all these mistakes. I'm going to zoom back. Boom, boom. So you take the highest population, you take the highest price person and divide by their integer you got in the step 1 plus 1. And then notice what this does to our new modified divisor. What is it compared to our other divisor, bigger or smaller? It's less. And what happens when you divide numbers by a smaller divisor? The numbers go up. We want 23 to go up to 25. I hope it happens. But if it doesn't, wait till you see the strange thing you got to do. So now what we're going to do is take all of those numbers and divide by the modified divisor, which is now 39. So again, I cannot overemphasize the importance of the writing up here. This is the key. You take the state with the largest population, divide it by its integer you got in step 1, easy for me to say, plus 1 in this case, because you want a smaller modified divisor for the numbers to go up and maybe hit 25 on the dot. So that's why I showed you the calculator, because now what I can do is go to L3 and take L1. See, now we're getting somewhere. The setup early was long. Now everything's going to be fast. Divided by 39. Press enter. Okay, so, boom. New modified. I think one of these is wrong again. It's 4.61, actually 2 in that list. I should pull the screen, but you could see it. I'll pull it back up there. 7.56, 5.26, 10 on the dot, 4.62 actually, and then round down. Now this is what's not written in the notes. Now I'll zoom into this, okay? I'm going to zoom into this. Here's an issue. Now we have what? When we had 7, 5, 10, and 4. Too many. Well, now what do? We can't keep modifying the divisor by adding another one, because then the numbers are just going to get bigger and bigger because the divisor is getting smaller and smaller. So whenever you go from too few to too many, this is what you do. You take the last two divisors. This one created too many bottles given out. This one created too few bottles given out. This one made too many. You take these last two divisors and find the average of those divisors and keep going. So I got to divide again. And again, this is just Jefferson's method. It is crazy, and it creates a couple steps, and you may have to find 3, 4, 5 modified divisors before you hit it. That's why I'm showing you the calculator. Because the only math you have to do off to the side is this. You got to figure out what the divisors are, then you can go to the calculator list and go ahead and do the divisions real fast. So, the reason we are finding the average of these two is because we went from too few given out to too many. So, it's somewhere in between the divisor that works. There's a divisor in between these two that gets me bottles that end up being 25 on the dot. So, the average of these two, 4280 plus 39 divided by 2 is 40.90. And now we're going to use that as a modified divisor and see if that gives out 25 bottles when we do our little thing. So, here we go. Boom, we'll do this one more time in a future example. I'm just going to stay in L3. I can overwrite these. I can overwrite them. I could go back to L2 and just use L2 every time. Doesn't really matter. So we're going to take L1, right? L1 is the overall list divided by, and then what was our modified divisor number? 40.9. Now, if this doesn't work, whoops, that would be a mistake. Delete that. Enter. Okay, now I look at this. 7.2, 5.01, 9.54. Move that over and then show this chart up here because this is where your work goes. Of course, this is in the way. Poor manipulation of the notes. Sorry about that. And then move this back over here. Okay, and I think we do have one more error on that. It's the 40.40 is actually 40.40. No, that actually works. 9.54, 5.01, 7.21. When I drop those decimals, then I hit 25 on the dot. So therefore, this is what we're going to do. We're going to give Jared 7, Michael 5, Robert 9, and Monica 4, because we round them down. And this adds up to the 25 bottles we were supposed to divvy up anyway. Okay, so is it fair or not? It's just different. And it really depends on the perception of the individual. Just like in the representatives, why it was so contentious over the years, what apportionment method was. It's not about fair. It's trying to be as fair with as many people as possible, but pretty tough to do. Out of the notes here, I pulled our last two examples. I pulled Hamilton's method. This is old notes. You don't have to write this down. Remember this from Wednesday? Easy. Same first step. Okay? Take the population divided by the divisor to get the quota. In this case, it was 18 million people for 300 seats. Did that, rounded down, and then Hamilton's method was just the highest decimal left over gets a delegate at a time, or gets a representative at a time. There was 3 left over, so that's how that worked. This is Lowndes. Same first step. Divide them all by 60,000. Round down. But then it was about the relative fractional part. So don't forget this. I put this on the notes. You can relook at it. Ah! You have an odd way of showing you're awake. You really do. All right? And then you delegate the representatives by the highest relative fractional part. Well, we're going to do the same one, but we're going to do it Jefferson's way. So guess what we should do? Go to the calculator and actually put our list down. But we know from that previous 2 examples, in both cases, we were 3 short. 3 short. Okay, so take a minute to put this down, and then we'll go ahead and do this on the calculator. And sorry, Inspires, I'm going to do it with my 84. Okay, so I got the list in here. And then, you could do, how do I get this list? Well, you had to divide by 18 million divided by 300, which was 60,000. So, L1 divided by 60,000, right? But wait till you see what I do in the next one. It's using the store feature. 72.08, 43.9, 82.7, blah, 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 blah. Okay, you round down. Well, here's the problem. The same problem as all of them. You're missing 3 delegates. Well, this is what you need to do. You need to take the biggest population. Who is that? 4967000 and divide it by what? Let's see if you have it figured out. Not 82. 82 plus 1. This is called the modified divisor. I'll call it D1. And then that's what I'm going to divide everything by to see what I end up getting. Okay, so why? This makes the divisor smaller, which makes all these quota numbers what? Bigger, and may start bumping them up 1 or 2. And then therefore you might end up hitting 300 on the dot. So that's why we add 1 to this 82. This makes this divisor smaller. So therefore when I divide by a smaller number, these quota numbers will grow. Remember I said that because that's in some Mickey Mouse questions in your homework about understanding division. Alright. Well, this is what I'm going to do on my 84. Second quit. Now it's a lot of setup, but me showing you on this calculator stuff, you get good with it. This should go fast. I'm actually going to put that number on my calculator. And then for you Inspires, just remember how to store an answer in a position. I'm going to divide that by 83. That's 82 plus 1. And then I'm going to hit the store button. And I'm going to store it in for X. If I did that too fast, the store button is right above the on button. and the X button is right next to the alpha button. Press enter so I do not have to type that long decimal out. Then I'm going to go into stats, edit again. There's my list. I'll just go to L3 just to see. It doesn't matter. I can go back to L2 and rewrite over L2. It's fine. But now what I can do is L1 divided by, now X. I don't have to write that decimal all the way out. All right? And I didn't even round. I have the full decimal in place that I wanted for this question. And then I press enter. Now I might pull this one off here. I don't know how big this is going to look. I knew it. Let's make it like a Godzilla. Yeah, good. Well, just type some buttons. All right? Okay. 72. Swear to who? Don't do that. 44. 83. Right? 50 and 50. Hey, this went up one, this went up one. That's it. So what are we up to now? 299. Bummer. Now this is the first time this happened. Is this too many or too few? Too few. So this is what we have to do for our next modified divisor. We have to take the largest population and do a second test. Not dividing by 82 plus 1, but dividing by what? 82 plus 2. That's what that formula meant, because I'm still too low. I'm still too low. It still didn't quite work out. And I'm not doing this pulling the screen again. You guys can tell me the numbers that are following along. And those that aren't, blah! That's all I have to say to you. All right, here we go. I'm going to overwrite L3, because I don't want to go to L4. So, second L1. I didn't do what I needed to do first. Sorry. Okay, I needed to take 4967 ... divided by, what's 82 plus 2? I got it. It's 84. Don't worry about it. And then store that value in for X. Now look at our divisor. Our divisor went what? No, our divisor went down, so my state numbers are going to go up. Now that I have that stored in for X, I can go into my stat edit and divide by that. I'm just going to overwrite L3. I'm going to rewrite L3 as L1 divided by X, because I changed that X. Boom. Okay, anyone that did that, help me out on the numbers. But I think I see 73, 44, remember you round down, 73, 44, 84, 51, 51 hike. Okay, so what was that? 73? Still 44, right? Was this 84? 51, 51. Uh-oh, everyone should know that this went up, this went up, this went up, and this went up. This went up 4. So how many have I given out? 303. Now what we just had is exactly what happened in the last example. It just took us one more step. So what do I have to do now since I went from under to over? I got to take the average of the last two divisors. So we'll look at my calculator screen. It ain't no thing, chicken wings. I got the last two divisor numbers right here, right? And with this fancy schmancy calculator, I don't have to retype them. Enter plus enter. It was right there actually, wasn't it? Add those two together, enter, then divide by 2. All I got was the average of the previous two divisors. You don't have to do what I'm doing here. You would have to just physically type them. Have them written down and then type them. Store X. Boom. Now I have 59,487. Go back into my stat edit. And I'm just going to use L3 again. L1 divided by X, because I stored it in there. Press enter. The last one, I'm just going to squeeze it in here. 7244, right? 7244. 835150. Now, luckily, this ended up equaling what? 300. And now we're done. So, Jefferson method is a little convoluted. It is a process. The process is not hard. It's just something that you have to Just kind of memorize what's going on here. So as far as math is concerned, how I would check a student's work, this is all I would need to see right here. I need to see all of these checks, the process building up to this. And I may ask for what the divisors are for each one, which would just require that you write it on the paper. And that would be about it. So tough one, all right? But it is what it is.